Theoretical probability. Our objective is to determine the theoretical probability of an event, as well as convert between probabilities and odds. Why learn this? Theoretical probability can be used to determine the likelihood of different weather conditions. Let's start with some vocabulary. Equally likely. The outcomes in the sample space of an experiment have the same chance of occurring. So equally likely outcomes would be like the spinner here. There is the same chance that the spinner will land on any of the colors. Not equally likely outcomes is when there is a greater chance that the spinner will land on blue than on any other color, for example. Let's look at some more vocabulary. Theoretical probability. The ratio of the number of ways the event can occur to the total number of equally likely outcomes. So this is slightly different than experimental probability. The number of ways the event can occur over the total number of equally likely outcomes. Something that is fair is an experiment in which all outcomes are equally likely. The complement is all the outcomes in the same space that are not included in the event. And odds, another way to express the likelihood of an event. Let's start by finding theoretical probability. An experiment consists of rolling a number cube. Find the theoretical probability of each outcome. So we have the outcome of rolling a 3. Well, a standard number cube has 6 sides, so that's your total possibilities. And we want to roll a 3. Well, one of those 6 possibilities is a 3, so 1/6. To put this as a percent, you would divide 1 by 6 and get 16 2/3%. How about rolling a number greater than 3? So the number of ways the event can occur is going to be 3, because we have a 4, a 5, and a 6. So there are 3 possibilities of this happening. So that's the number of ways the event can occur, and the number of sides on our cube is still 6, which gives you a 50% chance. So when you toss a coin, there are 2 possible outcomes, heads or tails. The table here shows the theoretical probabilities and experimental probabilities of tossing a coin 10 times. So the experimental probability, it landed on heads 3 times out of the 10 times you conducted the experiment. It landed on tails 7 out of the 10 times. If we put the 2 of them together, it will total to 1, 100% of the data. Theoretical probability, you have a 50% chance, so a 1/2 chance, so a 1 out of 2 chance of getting heads, or a 1 out of 2 chance of getting a tails. When you put your theoretical probabilities together of the event happening and not happening, you still end up with 1, or 100% of the data. So now let's look down below. The P means probability. So the probability of the event happening plus the probability of the event not happening needs to total to 100%, or 1. You can also think of it as the probability of the event plus the probability of the complement of the event. Because if you remember, the definition was all the stuff that wasn't the event. So therefore, the complement of the event is the same thing as the event not happening. Let's take a closer look at that. Finding probability by using the complement. The weather forecaster predicts a 20% chance of snow. What is the probability that it will not snow? So, there's a 20% chance that it will happen. So what is the percent chance that it will not? Well, 100 minus 20 gives us 80. So the probability that it will not snow is 80%. So now let's look at odds. Odds in favor of an event. The number of ways an event can happen to the number of ways an event can fail to happen. Notice how there's a colon in between them. Odds are usually written with a colon, with numbers, so replace your A and your B with two numerical values. The two numbers that are given, the A and the B value, or the number of ways an event can happen and the number of ways an event can fail to happen, the two numbers given as the odds will add up to the total number of possible outcomes. So just like in odds against, when it's odds against the event, the number of ways an event can fail to happen comes first with the colon, and then the number of ways an event can happen. Once again, together they make up the total. So you can think of it as part to part, not part to total like you see in probability. So you can use this relationship to convert between odds and probabilities. Let's take a look. So converting between odds and probabilities. The probability of choosing a red card from a standard deck of playing cards is 50%. What are the odds of choosing a red card? For probability, you can think of the probability of this event as being 50 over 100. So that's your part to your total. So now when you try to write it as odds, you want a colon in between, and you want the part that's in favor and the part that's against. So the odds in favor are 50 and the odds against are 50, or it's a 1-to-1 for odds. Equally likely to have it happen as not. Let's try a few more. The odds against choosing a green marble from a bag are 5-to-3. What is the probability of choosing a green marble? Well, what are the number of ways that it can happen? Well, if the odds against, so this first word here, we got the against. Because they say against, that means the 5 represents not. So that's not going to be your green. So your green is your 3. So the probability or the number of ways the event can happen is 3. The total possible outcomes are 8. So the number of ways the event can happen are 3, and the total possible outcomes are 8. Let's try another one. The odds in favor of winning a contest are 1-to-9. What is the probability of winning the contest? So we have odds in favor, so this 1 represents the in favor part, and we want to know the probability of winning. So therefore, the 1 is the number of ways the event can happen, and the total possible outcomes, you would add them together to get the total possible outcomes. Sorry about that. So your probability is 1/10. Alright, so now let's look at the probability of rolling a 2 on a number cube is 1/6. What are the odds of rolling a 2? So remember, odds, you're going to use a colon, and the two numbers that you write are going to total up to this 6. So we want the odds of rolling a 2. So those are the odds in favor of rolling a 2. So that can happen one of the times, but how many times is that not going to happen? 5. Both of these add up to the total. So odds doesn't have a total number. It's got in favor and not in favor. Probability has the number of ways it can happen on top over the total possible outcomes. And that concludes our lesson on theoretical probability.